The motor winds in the cable with a constant acceleration such that the 20 kilogram crate moves a distance S equals 6 meters in 3 seconds starting from rest. Determine the tension developed on the cable. The coefficient of kinetic friction between the crate and the plane is 0.3. So, in this problem, we have a given figure. So, this is a rectilinear motion on inclined plane. So, in order to solve the problem, let us first establish a coordinate system. So, we are having here an inclined motion. So, this motor winds the cable, resulting to an upward inclined linear motion. So, let's make this our x-axis, which is parallel to the plane, and your y-axis perpendicular to the plane. Now, let's create the free body diagram. So, let's redraw. So, this is your y-axis, this is your x-axis. So, the weight acts here. So your weight has y component and x component. You have your wy and wx, and here's the angle of inclination theta. Therefore, if we redraw the Fbd diagram here, so this will be your block with the y component of weight, which is equal to w cosine 30 degrees, and we also have here your x component equals w sine 30 degrees. Now it is being pulled by a cable. So here's the tension force created by the pulling of the motor. Then we also have our frictional force here. So it acts in between the plane and the block. So we have F sub F, and we have the normal force F sub N. So those are the forces acting on the system. So after completely listing down all the forces that acts on the system, let's create the summation of forces. The equation, summation of forces along x is equal to mass times acceleration along x-axis. So, wherein we have positive for direction to the positive or to the right. So we have T minus Wx minus the friction is equal to mass times acceleration on x-axis. Therefore, T is equal to M AX plus WX plus the frictional force. So now let us first compute for these components. So first, let's solve for the acceleration. So it is said that when S is equal to 6 meters, as the crate moves at the distance 6 meters in 3 seconds starting from rest. So therefore we have S equals SO plus or SOT or S equals VOT plus 1/2 AT squared. So here S is equal to 6 meters. Then the initial velocity is equal to 0 multiplied by time, so that is 0 plus 1/2 times A, here T is 3 squared. So we have A equals 6 times 2 over 3 squared. We have A equals 1.33 meters per second squared. Now let's solve for WX. So WX equals M multiplied by G sine 30 degrees. So WX equals 20 kilograms multiplied by 9.81 meters per second squared. So that is your gravity, sine 30 degrees. WX equals 20 times 9.81 sine 30. So we have 98.1 newtons. Now let's solve for the frictional force. So the frictional force is equal to the coefficient of kinetic friction multiplied by the normal force. And the normal force can be solved by summation of forces along y is equal to 0. So we have the normal force equals Wy, that is equal to mg cosine 30 degrees. So that is, by substitution, equal to 20 times 9.81 cosine 30 degrees. The normal force is equal to 20 times 9.81 cosine 30 is 169.91 newtons. Now we can solve for the frictional force, that is equal to mu, that is 0.3 times the frictional force of 169.91, and it is equal to 50.97 newtons. So we have the three values. We have the frictional force, we have Wx, we have the acceleration. So we can now solve for t. So by substitution, we have t equals max plus wx plus the frictional force. So it is equal to the mass of 20 kilograms times the acceleration of 1.33 meters per second plus 98.1 newtons of Wx plus 50.97 newton of frictional force. So we have 20 times 1.33 plus 98.1 plus 50.97. So we have T, that is equal to 175.67 newtons, and that gives the value of the tension for the wire. So that is 175.67 newtons.